Hello and welcome to this course on building a responsive app in Flutter. By joining this course, you will learn responsive design guidelines and how to implement them in your next Flutter app. Here is an app that adapts to any screen size responsively. By the end of this course, you will be able to build this responsive app yourself. Compare this with a non-responsive app here. This app's layout would work fine on a large screen, but when it's run on a small screen, it's hard to see its font and interact with its user interface. Its app users would simply move away to another app. But when you build the same app with responsiveness, it adapts nicely to a mobile device. For a multi-platform app with a single code base, the app UI needs to adapt to any screen size and any device. In other words, it needs to be responsive. Here are the challenges you will face when building a responsive app. How to handle your app UI for so many different screen sizes and devices on the market. And how many layouts would you implement for each app screen? And what would change in each of these layouts? Is it complicated and takes too long to build responsiveness? In this course, we will address all these challenges. First, I will take you through the responsive design theory. Then I will show you how to implement these design guidelines and patterns in a Flutter app. Not only that, I will provide a full code walkthrough of the Places responsive app. You will be able to download the source code of this app at the end of this course. By the end of this course, you will learn both design and implementation, and you will be able to build your next Flutter app that works responsively on any screen size, any device, and any OS platform. My name is Naresh Idiga. I'm a senior Android consultant and founder at Roboto Systems. I have been obsessed with app development for more than 10 years, and I have been developing software for more than 14 years. I hope you enjoy this course and learn the fundamental building block of developing an awesome app. Enroll into this course now and build your next Flutter app responsively. In this session, let's understand about how to implement responsive design in your app and provide a great user experience. Here is an example of an app layout that is developed for a large screen, but it will result in a poor user experience on a mobile. Users cannot see what is going on here. They cannot understand what these icons are indicating. So a non-responsive design results in a bad user experience. It makes it really hard to use the app, and your users will obviously move away to some other app. So enter responsive design. Under responsive design, we will try to adjust our app content, our app's screen content to various screen sizes, so that our app screen will look nicer on any kind of device. So here is YouTube app appearing on a large screen. So this is taken on Mac OS Chrome browser. So here you can see that the side navigation menu and each item, we can clearly see it. And when we move to a medium screen size, when I resize the window to a medium size, you can see that side menu is now collapsed into a menu with icons and labels, right? And then when I resize the screen to a small size, now the menu is completely collapsed and a button is provided for us to open the menu. So this provides a better, and in fact a great user experience for the users, because now they can interact with the app without any problem, irrespective of the size of the screen or the platform they're using. So what are the important things to consider to implement a responsive design? So number one is how many layouts are you going to implement, and then how to adopt our UI structure and the UI components for various screen sizes, and what are some of the principles and patterns that you can apply so that it makes your life easier when you are dealing with a responsive design. because without any set of principles and patterns, we will be lost. We will be thinking in our own customized way when there are patterns that already solved the problems. So enter Google's material design, and Google's material design provides us some very good guidelines on how to implement a responsive layout. So here we have one fundamental concept called responsive layout grid. So responsive layout grid is simply means that we will imagine our screen as a grid layout containing a set of columns. Okay, and for each screen size we would imagine the number of columns would change. That is why we call it as a responsive layout grid. So responsive layout grid has these concepts that we need to understand in order to implement them. We will be going through each of them now, and then in the next session we will go through the patterns involved in implementing responsive layout. So in this session we are going to focus on these concepts. So let's take a look at pixel density. So pixel density, what is pixel density? So pixel density means that the number of pixels tightly packed in a space. So typically we use notation like dp or dip, which simply means density independent pixels. dp is a unit that is also called as different names on different platforms. For example, on web you would call it as logical pixels, and iOS it is called as points, and Android it is called as dp. The actual pixel size is much smaller, and you are tightly packing them and calling one logical unit which may contain more than one pixel. And there is another term called DPI or PPI, which means dots per inch or pixels per inch, which simply means that in 1 inch how many pixels have been packed. So by using the unit as DP inside your app, you would have the UI elements look as same screen size irrespective of the screen density. So here on the left hand side we have a low density screen, and here we have a high density screen with more pixels packed in the same space. But if you look at this floating action button in the circular shape, it would appear as same size on both the screens. And what are the other things that we need to know about DP or the logical pixels? So here I have some examples to explain it better. So we have some devices like Nexus 10 that is containing a width of 1280 dp and a height of 800 dp. So which means its logical resolution is 1280 by 800, whereas its real resolution is actually 2560 pixels width and 600 pixels height. So which means we have a density of 2 pixels per 1 dp or 1 logical pixel. Okay. So similarly for iPhone 6 Plus, you have 3 pixels for 1 logical pixel or 1 dp. So the real resolution is 1080 by 1920 pixels, whereas the logical resolution is 414 by 736 for iPhone 6 Plus. So the screen sizes can change, but every screen size will be always be resolved into a logical resolution, and we are always we will always define the sizes in your app using the logical pixels, so that they will fit the logical resolution, which will ultimately result in the real resolution. So that the images or the sizes of the views, they would all appear uniformly on screens of different density. Next, on our responsive layout grid, we have a few things like columns, gutters, and margins. Let's take a quick look at them. Columns is nothing but how many number of columns that we are dividing our layout with. So this is typically useful as a notation to understand. Well, so if you have a small screen, large screen, and a medium screen, and material design guidelines tell us some recommended number of columns to use. For example, here a 360 dp screen is recommended to have a 4 columns, whereas a 600 dp size screen is recommended to have an 8 columns size. So you are actually dividing the screen into number of columns um, based on the screen size. And then gutters are nothing but the space between the columns. So this is a 4-column screen, and we have the gutter of a size of 16 dp or 16 logical pixels, whereas on the tablet you have a 24 dp gutters, and this is of course at 8 columns. Similarly, margins are the ones at the border of your views, and this margin space, as you can see here, on a 4-column grid you will go with a 16 dp margin, and on a tablet size or a medium size screen it is recommended to have a 24 dp margin. And also, it is not necessary that you should always have bigger gutters or a fixed gutter for each screen size. For example, here you can customize the grid layout with a small gutter. So here, even though this is a medium size screen, the gutter is only 8 dp. This is to indicate that, so my album here has pictures, and all these pictures are closely related, and they all belong to one single album called my album. Whereas here I am displaying a list of albums, and to indicate all these albums are individual entities, you can have a larger gutter between them. And when it comes to margin, depending on what you're building, here I have small margin so that I can have more space for these closely related images. Whereas here I have a larger margin to provide a good reading experience. And when it comes to the grid size itself, you can have these columns, since we are dividing the grid into a number of columns. For fluid grid, you can have these columns expand to the screen size. So if you are at if the screen size is medium, you can have the columns expanded. Whereas under fixed grid, the behavior is that you can have the size of the columns fixed, the size of the grid fixed, and the margin is expanded. Uh, and this is really like a preference, and you can decide what to go for, fluid grid or fixed grid, depending on what you are building. Breakpoints are quite useful to determine at which point we should switch from one layout to another layout. So we use the screen width as a factor and identify when the screen width reaches a certain breakpoint range, we switch from one layout to another layout. So here we have the breakpoint ranges. So material design recommends 600 dp as the first breakpoint. So anything below 600 dp, we will implement it as a small layout. So any screen size that falls below 600 dp will always result in the same layout. And for any screen width between 600 to 839 dp, we will define a medium layout. For anything above 840, we will define a large layout structure. So we have 3 different layouts that will work for 3 different breakpoint ranges. So this is the first breakpoint range, this is the second range, and this is the third range. So here we have like a detailed guideline. You can check out the material.io website this table to understand it more better, but the gist of it is that you can have the grid as containing 4 columns for a small layout, and 8 column grid for a, you can divide your medium screen into a 8 column grid, and your large screen into a 12 column grid. And at the point at which you are going to switch between the small layout to medium layout is 600 dp, and from medium to large layout is the 840 dp. So we are going to define usually 3 layouts and adjust the layout structure, and we will apply the responsive patterns that we will learn in the next session to provide a great user experience for each layout size. So to summarize what we learned in this session, we looked at what kind of problem a non-responsive design will result in, and how to better design using responsive design principles. And we are actually going with Google's material design guide because it is solid and covers many scenarios. So under material design guide, one of the fundamental concept is responsive layout grid, which is an imaginary grid that we are going to divide our screen into. The grid itself will contain a number of columns, and the grid is going to have margins and gutters, and pixel density is used to declare uniform sizes across multiple screen densities. And you can also have the grid itself customized with slightly larger or smaller gutters and margins. You can have a fixed grid or a fluid grid, and finally breakpoints, which will tell us when to switch our layout between the small to medium or medium to large or vice versa. In the next session, we will learn about responsive design patterns and use them to arrange UI components within a small layout, medium layout, and a large layout. In the previous session, we looked at building a responsive layout using the concept of responsive layout grid, under which we imagined our app screen as a responsive layout grid. We defined 3 layouts: a 4 column layout, a 8 column layout, and a 12 column layout to adopt our layout grid for various screen sizes. And for simplicity, let's call them as small layout, medium layout, and a large layout. Now let's look into responsive patterns. These patterns are quite useful to arrange UI components in a small layout or a medium layout and a large layout. Using these patterns, UI components can adopt their dimensions based on screen size and device type. Now let's take a look at each of these patterns. The reveal pattern can be applied when our app screen size changes from small layout to a medium or large layout. When our app screen is showing a small layout, we are probably hiding some of the UI components to utilize the screen space. For example, here we have the side navigation menu that is hidden and on the small layout, and when the screen size increases to a medium or large layout, we can reveal this side navigation menu. And another example is that you have a toolbar in your app, and if on a smaller screen you are probably just showing a very limited number of options, but when the screen size changes from small to medium and medium or large screen layout, then you can reveal more complex options. The next pattern is a transform. This pattern is quite useful when you want to transform one UI component into another component. For example, here we have the side navigation menu, and when we have the larger screen available, the side navigation menu has been transformed into a tab bar. Okay, and another good example is when you have a simple list containing a single row items on a smaller screen, and when your app screen changes to a larger screen, you can transform this simple list into an image list. Next is divide pattern, using which when we have a multi-row items on a small screen, you can display it as a single row when you have large space available. So when your app screen changes from a small layout to a medium or large layout, you can divide the single row, you can divide the multi-rows into a single row. Another example of applying divide pattern is, for example, you have a tab bar on a small screen, and when your app screen changes to a large layout, you have more space available, so you can show each of the tab items as an individual item as shown here. So here the tab 1 is transformed into this box here, and tab 2 is showed in this next to it, because now we have more space available on the layout. Reflow is a useful pattern when you have a single column of items on a smaller screen and to transform them into a combination structure on a larger screen. For example, here we have three items A, B, C in a single column on a smaller screen layout. When it is transformed into a large layout, we have arranged the combination in such a way that A is arranged on the left side and B and C are arranged in a single column on the right side. Another good example of a reflow pattern is a time picker widget. So here the time picker widget is shown in a portrait, and here it is in horizontal, in a landscape mode in the horizontal direction. So the time widget is adopted to arrange the clock on the right side and the time values on the left side when you have a larger space available. Expand is another simple pattern where your UI component is expanded on a large screen to fill a larger space. For example, here we have a card item on a small screen, and when a bigger, larger space becomes available on a large layout, this card has been expanded. Another example for expand to apply expand pattern is a dialog. Here the dialog has been expanded from a smaller size to a larger size proportionally. The next pattern is position. So by applying this pattern, you are changing the position of UI elements. So here is an example of a floating action button. This floating action button on a smaller screen, smaller layout is positioned at the bottom right corner, and on a large screen it is moved onto an intersection of an app bar and the body of the screen. So far we have discussed about the responsive layout grid guidelines and the responsive patterns to apply on it. So now, coupled with this knowledge, you can design a responsive layout for your app screen. Once you design your app screen and develop it, you can test your app screen layout using the tool material.io resources.resizer. Go to this website and enter your app URL here and test in various modes here. So you can test on a desktop mode, or you can also test on a mobile or tablet mode. So here there are also the breakpoint ranges here. So you can test at various sizes, and this is a mobile and a tablet mode here. So this is quite a useful tool to test the responsiveness of the layouts that you have designed and developed for your app screen. So here is an overall summary of the responsive design theory we have discussed so far. So this is based on Google's material design guidelines based on the concept of responsive layout grid. So we imagine our app screen as a responsive layout grid, and we define three layouts. One is a 4-column layout, another is a 8-column layout, and the third one is a 12-column layout. We simply call them as a small, medium, and large layouts. And the responsive layout grid provides guidelines on the margins and the gutters to apply for each kind of layout, and also the responsive patterns that we need to apply when the layout size changes. So using these guidelines and the patterns, you can design responsive layouts for any of your app screens. To see a working code implementation of this responsive design theory, check out my video on implementing responsive design in Flutter. In this series of video tutorials, I am going to show you how to build a responsive app in Flutter. So here is a responsive app that changes its layouts as its window size changes. So this is the small layout, and as the window size changes, medium layout comes up, and then a large layout comes up. So here is what we are going to build in this app. So we have three layouts that we need to build in order for our app to be responsive: a small layout, and a medium layout, and a large layout. On the small layout, we have the navigation menu hidden, and it can be revealed using the top menu button. And on the medium layout, the navigation menu is revealed because we have enough space available. And on the large layout, we show all the details like the navigation menu, and the gallery changed into a horizontal gallery. So here we have a vertical gallery on a medium layout. It is transformed into a horizontal gallery. And then finally, the place details, whichever place we have selected, those details will be shown in the detail view pane here. So here is how our app will look like on mobile with the small layout, in the landscape mode showing a medium layout, and on a tablet it is showing a medium size layout by default in the portrait, and in the landscape it has a larger space, so it is showing a large layout. And on the desktop, on the Chrome browser, this is the preview at various window sizes: a small window, a medium window, and a large window. So before we get into the details, if you haven't seen my video on responsive design theory, do check it out because it contains guidelines and patterns that we are going to use in this session to apply on our responsive app. And it also gives you understanding on why we are implementing three layouts and when to apply some of these patterns. Now let's look into the implementation details. In order to build responsive layouts in Flutter, obviously one of the things we must tackle is how does our app know its window size has crossed a particular breakpoint range so that we can switch our app layout from a small screen to a medium screen size. And another thing to know is how does our app know the device has changed its orientation from portrait to landscape or landscape to portrait so that our layout can be adjusted accordingly. And the third important thing is how does an individual widget on the app screen know that it has a new larger space available and it can fill the space. So to solve these problems, Flutter provides us with three main widgets called MediaQuery, LayoutBuilder, and Orientation Builder. Using these three widgets, we can build the responsive layouts in Flutter. Of course, Flutter provides many useful widgets. These are very useful to manipulate or rearrange the layout structure and UI components. Next, let's look into the main widgets, how to use them and build responsive layouts. MediaQuery provides us with app window size, which gives us what's its current width and height. It also provides us device level information like what's the current orientation, platform brightness, and text scale factor. The way to get this information is to simply call MediaQuery.off method by passing the context, and you get all the data into MediaQuery data, which has not only size information but also the platform brightness, device orientation, and many more properties that you can use. Here we have the home page of our responsive app called Places in three different layouts: a small layout, a medium layout, and large layout. Together, it provides a responsive experience to the user. Let's now take a look at the code on how to implement using the media query data. So here we have our home page implemented as a widget, and the widget's build method calls the media query or .off method, which provides us with the size information, and we pass this size information to a method called getScreenSize, which will tell us whether the screen size is a small, medium, or large. If it is a small, then we are going to build a home page a small layout widget, or we are going to build a medium layout widget if it is a medium screen size, and a large one if it is a large screen size. So the code for the get screen size method is here. So here we have two different breakpoint ranges defined, and we use this breakpoint range to test what's the current screen width is. If it is below our first breakpoint, which is 600, then we consider the screen size as small. If it is if it is between 600 and 840, then we consider it as a medium screen. Anything above the breakpoint range 840 is considered as large. An important thing to understand about media query widget is that whenever you call media query method inside the build method of a widget, that build method is going to be called every time there is a change in the media query data property. So you have a change in the size, it will be invoked. You have a change in the device orientation, the build method will be called. You have a change in the text type scale, this build method will be invoked. Now that you know how to use the media query widget and find out the screen size, let's take a look at how each of these methods, homepage small, homepage medium, and homepage large, are implemented. Let's start with the homepage small layout. The homepage small layout is implemented as a scaffold widget containing an app bar and a drawer. And the drawer is the one that reveals the navigation menu. It is implemented in this method called drawer body. And the body itself is implemented as a widget called places gallery that will result in showing this grid gallery with pictures, each picture containing a title and a subtitle. Now let's take a look at the homepage medium code. The homepage medium layout is also implemented as a scaffold widget containing an app bar that shows up the title here. And notice that we don't have any drawer here because in the medium layout we have more space available. So we have combined our navigation menu along with the grid gallery into a row widget, and the row widget is the whole body containing two children, and both of these children are implemented as expanded widgets. Expanded widget provides us with the flex factor, which we can utilize to provide the amount of space relatively each child will occupy. So here if you observe, the navigation menu is given a flex factor of 2, and the grid gallery is given a flex factor of 5. So it means that the whole screen width is divided into 7 parts, and the first 2 parts is given to the navigation menu, and the remaining 5 parts is given to the grid gallery. For implementing the grid gallery, we are reusing the same widget places gallery, that we have used in our small layout as well. Now let's take a look at the large screen layout implementation. Notice that in the large screen layout, the grid gallery is transformed from a vertical gallery to a horizontal gallery, and we have a new item appearing here, which is the place details. So let's see how it is implemented. So the homepage large is also implemented as a scaffold widget containing an app bar, and the rest as a row. The body is a row which occupies the full width, and this full width is divided into 4 parts. The first part is given to the navigation menu, and the remaining 3 parts is given to the container that contains the horizontal grid gallery and the place details widget. Let's take a look at how this container looks. So this container is containing a horizontal grid gallery and place details. They are implemented as a column containing 2 children, which both are expanded widgets. Notice that we have divided our column into 3 parts. The first part is occupied by the horizontal grid gallery, and the remaining 2 parts is occupied by the place details widget. With that, now you know how to implement 3 types of layouts based on the screen size information that you can get from the MediaQuery. So now you know how to use the MediaQuery widget. Next, let's look into the Layout Builder widget and how to use it for building layouts and widgets of different sizes. Using Layout Builder, you can build a layout or a widget in varied sizes. One of the benefits with Layout Builder is it provides you with local size constraints for a UI component. For example, if you wrap a widget inside a layout builder, every time there is a change in the app window size, the build method will be called and you will receive the box constraints which will have minimum width, minimum height and maximum height boundaries that your widget can take. But in case your widget needs to cross the size constraints, if your widget wants to go bigger than the box constraints provided, then you can wrap your child widget in a single child scroll view or a overflow widget. Similarly, if you need your widget to be smaller than the provided box constraints, then you can wrap it in a align widget so that that widget will be shown in the appropriate position in the overall space available. Here is an example of a widget that is built in 2 different sizes using Layout Builder. To use Layout Builder, simply return Layout Builder inside the build method of the widget for which you are building. Once you return the layout builder from the build method, every time there is a change in the app window size, the layout builder method will be invoked. This builder method will pass us the constraints which contain the current min and max width, min and max height values. So using the max width here, we are determining what is the current breakpoint range is like. So if it is crossing 600, we are building a large widget. If otherwise, we are building a small widget. So here is a code to build the small widget. We have built the small widget using a list view containing children because the layout items in this widget are going to cross the height of the window. So we kept them to be scrollable. For this reason, we used a list view. The same thing can be achieved using a single child scrolling widget containing a column as its child, and the column can contain the same children that we have here. So as you can see here, the first one is the image, and here we have the title section, and then we have the button section, and then we have the text section, totally 4 children under the list view. And here is a code for the large widget. Here you can see we have implemented this large widget using a single child scroll view containing a card, and the large widget itself uh, needs to be scrollable because sometimes if you are viewing the same thing on a mobile in landscape mode, the height may be very small, that you still need these widget to be scrollable. The body of our large widget is divided into two equal parts by using the expanded widget. By default, if you don't mention the flex factor for expanded widget, it will be 1. So here we have two expanded widgets as the children of a row, and this row becomes is the body of the card which is inside a single child scroll view. And the first child is showing all the image, the title and the subtitle, and the second child is showing the buttons section and the text section. So now you know how to use the layout builder. To quickly recap, simply use the layout builder, return the layout builder from the build method of the widget which you are building. Use the box constraints coming in the builder method, and decide what should be your widget size. To compare layout builder with MediaQuery, MediaQuery is quite useful to know app level information and device level information. MediaQuery doesn't provide any information at widget level, but using layout builder, you get the box constraints which are very specific to the widget we are building. Layout builder doesn't provide app level information. So in summary, use MediaQuery widget when you are dealing at app level, and use Layout Builder when you are dealing with widgets. With that, now you know how to build responsive layouts using MediaQuery and Layout Builder widgets. Apart from MediaQuery and Layout Builder widgets, Flutter also provides us with Orientation Builder widget, which simply provides orientation. To use Orientation Builder, simply return Orientation Builder from the build method of your widget, very similar to the Layout Builder. And every time there is a change in the orientation, the Orientation Builder's builder method will be called, and you get the current orientation in the orientation property. Based on the current orientation value, you can adjust your UI widget accordingly. So in cases where you simply need the orientation, you can use the orientation builder. Otherwise, layout builder and media query widget will solve most of the problems to build responsive layouts. By using the concept of adaptive components, you can take your responsive app to the next level. The idea behind adaptive components is very simple. Let's say you have a UI component as shown here. And by using the concept of adaptive components, you will build slightly modified versions of the same UI component as shown here. So here we have three categories. So the first category is based on when you have more width available. And the second set of three layouts are based on when you have more height available. And this third one is based on when you are constrained both by width and height of the widget. So the slightly modified versions come here based on the availability of the size and the device type you are dealing with. Let's say your widget has more width available than height, then you can build these four variations, and you can see the difference is that here you have a subtitle, here you don't have the subtitle. Similarly, you have a multi-line title here and no subtitle, and whereas here you have a subtitle. Similarly, when you have more height available to your widget than the width, then you can build these three variations. Here, the difference being this layout shows a subtitle, whereas the other two doesn't show. So this has a larger width and height compared to this one. Similarly, when your app widget is constrained by both width and height, we are simply overlapping the title on top of the image. And this is the smaller version. This is much more useful to display on a device like a watch. So by using the concept of adaptive components, you can build really rich user experience and make your app more responsive. So to summarize what we have done so far, we have built three layouts: small layout, medium layout, and large layout for the home page of our Places app. And we used MediaQuery widget to query the current app window size and decide between whether to build a small layout or a medium layout or a large layout. And then we used LayoutBuilder to build our UI component in a small size and a large size, depending on what's the current box constraint that LayoutBuilder has passed to us. We also discussed about the concept of adaptive components, using which you can build slightly modified versions of your UI component and build a rich user experience in your app. In the next video, I will take you through the complete code of the Places app that we have seen in the previous videos. In this video, I will take you through the source code of the Places app that we have seen in the previous videos. Here is the preview of our Places app, which changes responsively as the screen size changes. So here is the source code of our app. This is our main entry point, Places responsive app dot dot, that contains the main function which calls our Places app, and which is a stateless widget that implements a material app widget. And then we have our assets placed in the assets directory. All of the images that are used in this app are present here. And we access these images by going to pubspec.yaml and declaring -assets/images under assets. So it is important to make sure this formatting space stays here. Otherwise, Flutter will throw you error and that it is not able to find your images. And whatever the folder name you use here, this can be assets, this can be images, or this can be anything you want, but you have to provide the same name here. So assets and followed by images. Our Places app contains only two pages, a home page and a place details page. Like this is our home page, and then you tap on any item, it will show a detailed page. And these two pages reuse the widgets that are present here. The Places Details page uses the Place Details widget, and the home page makes use of the Places Gallery widget. And all the data that we need for our app is present in the model. We have place dot dot, which has the class for representing the image, title, and subtitle. And the places data dot dot contains the actual data that will fill each of the place object with the data we need. We use all the images present in our assets images folder, and we have title and subtitle for each of the item here. Now let's go through the code starting from our main entry point, the main method, which calls the Places app. And the Places app is a material app, and its theme is defined with a primary swatch of a deep purple color. Then it has a home page defined here. Our home page is implemented as a stateful widget. The home page state contains a state variable selected place, which we will use to keep track of the currently selected place by the user. Our homepage state has a build method which implements three types of layouts. So our build method calls MediaQuery method, MediaQuery.off using the context. And then based on the MediaQuery size information returned, the get screen size will decide what is the screen size depending on the breakpoint ranges we have defined here. So the get screen size method will tell us whether the current app window size is a small screen or a medium size or a large size. And based on that, we will build either a small layout or a medium layout or a large layout. So here we have the code for homepage small, homepage medium, and homepage large. Even though all the code is present in a single file here, you can also move these widgets into separate files, which will make it easier as the code size of this homepage file grows larger. And the app bar simply contains the text that we are showing in the title place, and the drawer body contains the code for the navigation menu that we show on to the side. So let's go through each of these methods. Homepage small. So the homepage small contains a scaffold widget implementation which has an app bar, a drawer, and a body. So this app bar shows up the title, and this drawer implements a child called drawer body, which is our own method. The drawer body contains a list view, which is building a drawer header and a list title. We can see this drawer here. When you tap on this icon, it shows the header here. This is the header part that we can see here, and the remaining items are implemented as list tiles. And the body of our homepage small itself is implemented as a grid view, scrolling vertically. The places gallery widget here implements the grid view. Now let's take a look at other methods. Let me minimize this guy so you can see what's going on here clearly. So we queried the media query, which gives us the size, and we read its width, and the get screen size tells us what is the screen size like. Is it small, medium, or large? We just had a look at homepage small structure. Now let's look at homepage medium. The homepage medium is also implemented as a scaffold widget containing an app bar, and it contains a row as a body. Let's see it here. As we resize the window, at some point it crosses the first breakpoint range 600 and reveals the navigation menu. So here in the homepage medium, we have a row representing the body, and the row contains drawer body as the first item, and the places gallery as the second item. Notice that we are reusing the same method, the drawer body, that we have used for our homepage small as well. And similarly, we are reusing the places gallery widget that we have used in the homepage small. Now let's take a look at the homepage large as well. So the homepage large contains a scaffold widget implementation containing an app bar and a row, similar to the medium screen. Now it also has two children with a different flex factors. Let's see it here. As we increase the medium size screen, at some point it will cross the 840 dp and it will enter a large layout. So it just crossed the 840 dp, and now we can see the horizontal gallery coming up here, and the detail view pan also shown up here. As you can see, the row is highlighted in the blue color here, and it is containing two children. The first one is our side navigation drawer, and the second child is containing a container that contains again two children, our grid gallery, our horizontal grid gallery, and place details. Now let's take a look at this container code. So this container is made up of a column containing two children, two expanded widgets, one with a flex factor of 1, another with a flex factor of 2, As you can see, this total height here is divided into three parts, and one part is occupied by our horizontal grid gallery, and the two parts is occupied by the place details widget. And the places gallery is now made to be shown as a horizontal grid view. So for that we pass this property as true. Now let's jump into places gallery. The places gallery is a stateless widget that builds a grid view, and based on the property show horizontal grid view, it will show either a horizontally scrolling grid or a vertically scrolling grid. So in this case here, it will show a horizontally scrolling grid by setting the axis as horizontal. This variable axis direction we are further passing to the grid view that we are building here. And the other case is the vertical direction, where when this property value is false, we set the axis direction as vertical and the item count as 2, so that 2 columns will appear in the vertical grid view. So here, this is a small layout where it is a vertically scrolling grid view that has 2 columns, and this is the medium layout, which is also showing the same vertically scrolling grid view. Whereas when we come to the large layout, now the grid view, we are passing the show horizontal grid view property as true, so it results in a horizontally scrolling grid view. The places gallery grid items are built using the method the grid items. Grid items method simply fetches the list of places. These list of places are coming from the class places that we have kept with all the data that we need for our app. Once we get the list of place objects, the map method iterates through each of these place objects, and a grid item widget is built for each of the place object. And then all the grid items that are built are converted into a list, and this list of grid items is finally returned by the grid items method to the grid view as its children. Now let's look into the implementation of the grid item itself. The grid item is implemented as a card, and this card is further implemented as an inkwell widget as its child, and inkwell widget will provide us with the touch feedback whenever you tap on the item, and this contains a grid tile as a child. This grid tile contains a footer object, and this where using which we can provide our title and subtitle values, and also set a background. So this results in a grid item with the footer here, okay, with the background and a title and a subtitle. And then we have the image, the actual picture here as an ink image widget. So whenever you tap any of these grid items, we receive a callback in the onTap method of the grid item. And depending upon the current screen size, we decide whether to navigate to the place details page, or simply to update the details page here. So if we are in a if we are in a small or medium layout, whenever you tap on the grid view item, we will navigate to the place details page. Otherwise, if you are on a large layout, whenever you tap on any item, instead of navigating to the place details page, we simply show the place details widget here. But how does our grid view pass the selected place details to the place details widget? It cannot communicate directly. There is no direct link with the place details widget. So someone has to take responsibility for taking the details of the selected place and pass that information to the place details widget. So because of that, we have our home page widget implemented as a stateful widget, and it keeps track of the selected place. And so whenever the grid item is tapped, the grid item, the grid view will give a callback to our home page using a handle place changed. If you have observed, this handle place changed is a method, is a function callback that is being passed to our grid view, and this has been passed from the grid view to the grid item as a input argument. Let's go back and see where it is coming from. So the places gallery receives a handle place changed, that same argument, and whenever we call the places gallery from the home page, this argument is passed, and in the home page we have this function actually defined here. So whenever user taps on the grid item here, a callback is received by the home page in this method called handle place changed with the new place details, and we simply update the new place details to the selected place variable, the state variable that we have here. And since we are calling the setState method here, it will trigger the rebuild of the home page widget. So it will call the build method again, and now we have the selected place containing the new place details instead of the default place value, which is the default thing comes from the get places, and it will by default select the first item here. Okay. And now since we have the new place selected, it will when it is building the layout, whether it is a home page small, medium, or large, and in our case it is building a large layout. And the large layout contains the place details as one of its child widget, and this will now show up with the new place details. So what we have done here is we have assigned the responsibility of keeping track of the new place selected by the user to our home page widget. And the home page widget will rebuild the screen whenever the set state has been called, and effectively setting the new place details. When it is building the home page large layout, it passes the newly selected place as an input to our place details widget. Let's next take a look at the place details widget. The place details is a stateless widget that is built using a layout builder. This, as you understand, the layout builder will give you a callback to the builder method every time there is a change in the app window size, and it will pass us with the constraints that are available to our widget. Based on these constraints, now we can build either a large widget or a small widget. So in our case here, we are building a large widget because it has more than 600 dp width available for our widget. Now let's take a look at the implementation of our large widget. So the large widget layout is implemented as a single child scroll view because this content needs to be scrollable. Sometimes the images can be bigger, or sometimes the content here can go larger than the height available. So we need to make it scrollable. The single child scroll view contains a card widget as its child, and the card is this whole layout, and then the card itself is implemented as a row as its child. So this row has two children. So one is the one in highlighted in blue color, and the second child is the one highlighted in green color. So the first child is an expanded widget which contains a column as its child, and this column is containing again multiple children in the vertical direction. As you can see here, we have an image here, that corresponds to this image, and a title section that is going to show this title, subtitle, and star and 41 here. And then the second child, this is also implemented as a column containing multiple children in the vertical direction, and it has a buttons section that implements these buttons, and followed by the next child containing a text. Let us now take a look at the small widget version of the place details widget. So here we have the large widget and small widget. Let's jump into small widget. Small widget is implemented as a list view with containing multiple children. You could also implement the same as a single child scroll view containing say a single child as a column, and then that column can contain multiple children with the same code here. This small widget version will be shown when our app is showing a small layout, and when you tap an item, it shows up this small widget version because it does not have a larger width available. As you can see here, our list view has 4 children. The first one is an image, and the second one is a title section showing this section of the layout. And then the third one is a button section showing these 3 buttons. And the fourth one is a text section showing the text at the bottom. Now you know how the place details widget has been implemented in a large widget and a small widget version. Notice that we are using the same places widget whether we are at home page or whether we are showing the detailed page here. So this place details widget is used in home page as well as place details page. Here is the code for the place details page, which is a stateless widget, and it is being passed the currently selected place as its input, and it is built as a scaffold widget containing an app bar, and it uses the place details widget we just gone through as its body. So here, whenever the app window size changes, our place details widget changes from the small widget to the large widget as it has more width available now. Our app navigates to place details page on medium and small layouts. On the large layout, however, because we show the place details widget directly, we don't navigate to the place details page at all. So whether we navigate to place details page or we simply update the place details widget here is decided by the grid view grid item. Because whenever we tap on this grid item, we receive the callback in the grid items on tap method. So this is the code for the grid item that we have previously gone through, which is built inside the grid gallery. So this grid item contains the on tap method, which simply gets the current screen width using the MediaQuery, and we call the get screen size method to tell us whether we are dealing with a small size or a medium size screen or a large size screen. If it is a small or medium size screen, then we navigate to place details page. Otherwise, we simply call the callback method that we have defined in our home page and update the newly selected place details. And then our home page will trigger a rebuild because we call this method and we invoke the set state method here. Our home page will be built again. So now with that, we have gone through the source code of the Places app, and you now know how to build a responsive app using the MediaQuery widget and LayoutBuilder widget. And finally, here is how our Places responsive app looks on a mobile and a tablet. and on the desktop. If we have observed, we have applied guidelines from the responsive design theory and we built three layouts: a small layout, a medium layout, and a large layout, corresponding to three breakpoint ranges that we discussed in our response design theory. And we have also applied some of the responsive patterns. We have hidden the navigation menu on a small layout, and we have applied the reveal responsive pattern whenever we have more screen width available, and we have revealed the side navigation menu. And then another pattern we applied is transformation of our vertical gallery into a horizontal gallery. So that is the transformation pattern that we have discussed in responsive design theory. So as the screen size changes to a large layout, our vertically scrolling grid has been transformed into a horizontally scrolling grid. And we have applied the reflow pattern on the place details widget by moving half of the details into another pane as the screen size increases. So here we have half the details in the left and the other half of the details on the right, as we have more screen width available now. And finally, we have applied the simple pattern expand by having our UI components adjusting and expanding to the bigger space available as the screen size increases. So here the navigation menu size has increased compared to when it was in a medium layout. And similarly, our place details widget also has increased in width as the screen size increased. So with that, now we have gone through the responsive design theory and applied the guidelines and responsive patterns and implemented them in Flutter.